The U.S. Army Corps of Engineers, or USACE, manages hundreds of locks and dams, which are critical components of a complex navigation system that is central to our nation's economy and security. Inspecting this aging aquatic infrastructure often requires costly and dangerous processes, such as deploying divers or dewatering structures, which shuts down the flow of goods and materials. To help USACE districts perform these inspections in a safer and more cost-effective manner, and with higher quality, the U.S. Army Engineer Research and Development Center, or ERDC, has been testing the use of an underwater remotely operated vehicle, or ROV.
I'm a former Navy diver, former Marine Corps combatant diver. I'm well aware of the dangers of diving. And anytime you send a person into the water, there's an inherent risk. And the underwater ROV, what allows us to do is to do a pre-site inspection. So we can understand what the problem is. And that then allows the dive teams to plan properly, to optimize their dive time, to really go directly to the root of the problem and fix the problem and get out. These locks and dams are still operational, so we don't shut down shipping traffic to perform the survey. And whereas if we have humans in the water, we absolutely have to shut that down. And so not only are we able to perform the surveys, but we're also able to maintain shipping traffic, which is a benefit to our industry.
ERDC researchers initially began working with this ROV technology as a part of a military-focused project. However, they soon realized that this capability could also be applied to solve a pressing civil works challenge.
The ROV was purchased to support an operation looking at underwater unexploded ordnance. And so that's kind of what we initially bought the ROV for. But then we quickly found out, after using the sonar and the laser scaling images and the video and things like that, that we could, hey, let's go off and inspect things. Or, after we're inspecting things, let's get into the research side of things.
It has been deployed in the Chicago Electric Dispersal Barrier to identify broken billets without any disruption to the canal's ship traffic. It has dived more than 80 feet down a vertical shaft to identify a large crack inside a culvert.
It's a pretty powerful little thing, so it could operate in some high-ish currents. It's small enough to fit into a lot of the smaller culverts and everything, and we have a really powerful multi-beam sonar that allows us to operate in really murky water.
The brains would be all the sensors, the cameras. They tell you all the information that's happening around you. The rover is just kind of the vessel that you're carrying all these cameras and sensors with.
We have done some modifications, like attaching a spray bottle to the gripper arm to squirt dye into certain situations to see where it flows into cracks and stuff, or if there's any flow at all, looking for cracks in a bulkhead.
In the New Orleans Inner Harbor Navigation Canal, the underwater ROV's multi-beam technology provided usable imagery in murky conditions with near zero visibility. This allowed engineers to diagnose and address the cause of a gate valve malfunction. Prior to using the underwater ROV, the district had unsuccessfully tried other methods and was considering the need to dewater the canal, which enables the passage of $4 million of commodities each day.
I think with this technology, there's a real opportunity here to just gather a lot of data that people have always kind of been scratching their heads and wondering, is it really like that? Is the estimate correct?
By conducting research into how to best use this off-the-shelf technology for underwater inspections, the ERDC team can test, validate, and develop systematic approaches and best practices. Their insight will help USACE districts know what works and what doesn't, and will enable them to fully capitalize on the transformative potential of ROVs for underwater inspections.
One of the great powers of ERDC is the fact that we do have such interdisciplinary teams. We have folks that are experts in operating in the environment. We have engineers who are experts in how to develop back-end networks or software. We have experts in AI and autonomy. We have experts in sensors and how we view and see the world. That is one of the great powers of ERDC, and that's one of the reasons why I really enjoy working at a place like this.